Hello, everyone, and thank you for joining us in today's webinar. My name is Alex Dashevsky. I'm the VP of Marketing for IoT Technologies, makers of the IoT platform. I will be your speaker today. Together, we will look into today's most prospective field for IoT technology, supply chain management. During this past year, my company's IoT platform had been utilized in a number of projects aimed at providing IoT functionality to logistics and warehousing operations. In this webinar, we will share with you our experiences and observations gained from these projects. In the first part, we will cover major trends, benefits, and challenges. We will look at the most effective methods of integrating IoT functionality with existing supply chain management systems and the importance of having interoperability between all your IoT solutions. In the second part of the webinar, we will review how IoT out of the box addresses most common challenges to implementing IoT in logistics, and specifically how IoT excels at creating private IoT platforms. The wide adoption of sensors, tags, and other IoT devices to track assets across the global supply chain are some of the fundamental use cases for the Internet of Things. This, however, does not solve all challenges for companies that want to plan and manage the flow of raw material and finished goods throughout their supply chain. Thanks to new advances in IoT technology, we now see a number of companies turning these challenges into opportunities. This slide shows how transportation and logistics compare to other industries in terms of investment in IoT solutions. Manufacturing, public utilities, and logistics comprise the broadest adoption of IoT. According to a 2018 study by Capgemini, into which IoT use cases were most beneficial and returned highest ROI, revealed that half of the top cases studied were in supply chain management. In these scenarios, IoT technology was integrated with inventory monitoring, inventory intelligence, smart metering, staff workload management, and others. The study also suggests that the majority of companies have not jumped on the IoT bandwagon and are missing out on the many benefits IoT has to offer. Based on our observations, companies that are considering using IoT find themselves at a crossroad, deciding what particular IoT case should be implemented first: warehousing, transportation, or last-mile delivery segments of the supply chain, for example. In reality, the key consideration should be more about understanding the convergence of any use case with another. This crucial detail will be the main highlight of today's webinar. We'll start by looking at the business requirements and how IoT can help companies drive profits up and keep costs down. First on the list is operational transparency and control over product integrity. Companies and customers want goods to arrive without delays, complete and undamaged. To accomplish this will require the ability to track goods, assets, vehicles, and employees in real time. Number two, cutting operational costs. This includes the ability to meter energy and water consumption at a facility, track fuel usage, staff workload management, warehousing, and transportation. Number three, ongoing efficiency optimization. This includes gathering and analyzing operational data, find ways for improving processes. Number four is customer care and a personalized user experience, such as web-based delivery tracking tools and robust mobile experience. These considerations alone can oftentimes be the main differentiator for a services company. Finally, safety and security is another area that can greatly benefit from IoT. The International Labor Organization reports that every 15 seconds, about 151 workers are at risk from workplace accidents. Globally, a striking 317 million non-fatal occupational hazards occur per year. The report also states that about 321,000 workers die annually from workplace-related mishaps. IoT can help in preventing a large number of these tragedies. Through the gathering of environmental data and monitoring workers and vehicles at warehouses in real time, IoT can alert managers, employees, and supervisors of potential hazards. Moreover, automated safety systems outfitted with sensors that can eliminate human errors and save even more. Moreover, automated safety systems fitted with sensors can eliminate human errors and save even more lives. For each of these 5 categories, we will show a separate slide describing the relevant IoT use case. Before we go into how IoT applications can help, we need to consider IoT applications in their evolutionary context. This is important because each IoT use case can be broken down into several stages, starting from basic data collection and monitoring to autonomous operation. That's why, in order to ensure the success of your IoT solution, it is important to acknowledge from the very start that long-term success will greatly depend on making continual improvements. In regard to fleet management, using IoT for telemetry and location tracking is a good start, but with IoT, it's best to approach problems from a bird's eye view. This will allow us to consider how our IoT solution will evolve to ultimately benefit your operation on a much broader scale. Now let's go back to our first category, operational transparency and integrity control. This category is front and center of IoT for logistics. Here we have IoT solutions handling fleet management, warehouse management, cargo integrity control, and optimized last-mile delivery. Each of these 4 groups comprises a number of high-value IoT use cases that, once implemented, typically result in an improved bottom line and an increased customer satisfaction. If we apply these use cases using our 4-step evolutionary framework, what we get is kind of a preliminary implementation roadmap. Having this will also help us to better understand what specific functions in the operation will benefit most from IoT integration and what functions are priorities. Following this framework, fleet management starts with vehicle telemetry and location tracking. Then other control features are added such as geofencing, smart alerts, notifications, remote troubleshooting, etc. Next is optimization, in which data analytics is used to implement functionality like route optimization and fleet capacity management. The final stage, autonomy, may seem a more distant goal, but in cases that involve technology like self-regulating storage environments or warehouse robots, autonomy is already happening. We predict that autonomy-enabling technology will be commonplace in the very near future because the cost associated with robotics has dropped significantly. Similarly, in warehouse management, IoT is used for basic asset management and inventory tracking via tagging technologies. Under control, we have connected workforce applications and smart energy solutions, which in addition to monitoring include functions for control and configuration of devices and software. In the optimization stage, our focus is on optimal asset utilization. By having machinery and vehicles connected via a central IoT system will enable warehousing managers to monitor assets in real time. Managers would receive alerts if an asset is overutilized or not being used efficiently. For optimized asset maintenance, it's possible to implement predictive maintenance alerts to address equipment malfunctions before they occur. Having these systems in place will provide the tools and information needed to make informed decisions on how we can implement other complex IoT solutions within the operation. In the second category, let's consider what companies and customers look to get from applying IoT in logistics. I'm not going to take a deep dive into this category as I did with the first, but it is important that the same approach is applied here, using these 4 stages of IoT application evolution. I will focus only on the general use cases. Here we have smart energy solutions for monitoring electricity consumption at a facility that helps minimize wasteful behavior. The implementation cost of the solution is minimal, but the benefits are great and accumulate over time. Staff workload management is more advanced. It helps ensure every employee is part of the effective process. Most companies already utilize some sort of workplace management system, which, when combined with IoT, can manage any connected asset, including employee scheduling or any combination of assets. Asset lifecycle management and predictive maintenance monitors the effective utilization of machinery and vehicles over time. These solutions can balance your asset's performance to minimize physical stress, prevent unplanned downtime, and prolong an asset's lifespan. Our third category is the ongoing optimization of efficiency. In this category, there's a broad array of IoT solutions. First is asset utilization analytics, which is basically collecting data and using it to optimize processes. In our opinion, data collection is not a panacea for all your problems, but it is common knowledge that a data-driven enterprise tends to outperform non-data-driven ones. So it is important that companies are familiar with using IoT to collect data, which can then be processed via enterprise analytics. Oftentimes, the value of ensuring a positive customer experience goes overlooked. Having such considerations can contribute much to your company's growth. Typically, it comes down to this: how fast can your staff master new technology, and how will your customers receive the benefits of IoT? In practice, optimizing the user experience with ongoing improvements to the system is what your customers expect and what your colleagues will appreciate on a daily basis. For this and other purposes, A and B testing is quite effective in figuring out the best way of doing things. For example, testing different versions of firmware on your machines, or comparing which user interface is best received by your clients. Finally, as your IoT ecosystem evolves, it is vital to ensure that there is a straightforward integration and data exchanges between the different solutions. Standalone applications may complicate workflows and compromise data integrity. That's why it's recommended to have some sort of centralized orchestration for your existing and upcoming IoT solutions. In today's marketplace, customers have the power to influence purchasing decisions and have many methods to reach customer service. IoT can help here in a number of ways. Providing your customers with tools to track the delivery of goods and ensure their integrity are essential. But when combined with features like flexible personalization, for example, providing clients with custom tracking devices, enhanced integrity controls for sensitive products, or automatic replenishments, a much bigger impact can be accomplished. Using IoT technology to accomplish these goals will help you meet and exceed your customers' expectations. Warehousing accidents are not uncommon. Occupational Safety and Health Administration states that forklifts are, in fact, the #1 cause of warehouse accidents, accounting for about 100 deaths and 95,000 injuries each year. Number 2 is chemical burns, resulting from spills of unlabeled or mislabeled hazardous materials. There are several ways IoT can address these and other work safety issues. By updating warehouse vehicles with collision mitigation systems, continuous tracking of workers' biometrics, using smart labels, installing air quality monitoring sensors and security cameras. Data collected by these and other devices can be used to automatically trigger alerts that notify managers, operators, or any relevant staff of potential hazards. Another challenge of the logistics industry is that many existing solutions are proprietary systems and do not communicate well with each other. In these environments, it becomes difficult to efficiently introduce new IoT applications and smart devices into the IoT ecosystem. So it is crucial to consider the importance of interoperability between IoT solutions. To address interoperability, a number of strategies have been implemented. Some companies choose to go with a premium vendor who will do everything for you. Some choose to invest into an in-house software development team, while others choose to implement an existing IoT platform. For the remainder of the webinar, I will share our vision on this matter and our recommended strategy to a successful IoT implementation. Let's get right into the title of the slide. A private IoT cloud based on an IoT platform. Our first recommendation is to use an IoT platform at the core of your IoT solution. Standalone, ready-made solutions from different vendors as they pile up become an integration nightmare. If a flexible middleware is not available to manage interactions between these different systems that can process data in a centralized way, your IoT implementation effort will be riddled with interoperability issues, belated customization attempts, and fragmented analytics. Using an IoT platform will create a single landscape for all your connected devices and applications. The second factor to success is ability to support a flexible cloud deployment and a cloud-based management of IoT clusters. In other words, your IoT platform should function as a full-scale IoT cloud, able to support the modern stack of cloud technologies. Now, the question is, should we go with a hosted platform as a service solution or an IoT platform that allows you to control deployment, operations, and data management? We believe the latter is a much better option for a long-term IoT strategy. We call this private IoT technology, having full ownership of your IoT solution. In this scenario, you'll have complete access to development tools, ability to deploy on private or public cloud infrastructure, open integration interfaces, and any flexibility over the deployment you need. In our experience, we have identified the key factor to a successful IoT deployment. Have ownership over your technology. This will ensure a fast time to market and eliminate dependencies on third-party vendors. Our IoT platform, Banana Beach, is designed and built specifically with private IoT technology principles in mind. Ka's core is open source, allowing you to retain full ownership and control over your IoT solutions. Ka IoT platform is feature-rich and is based on a cloud-native microservices architecture. I will briefly summarize the benefits of IoT technology ownership. Private IoT cloud technology gives you full control over features. An open source code platform allows you to modify it in any way you like. Flexibility to deploy in private, hybrid mode, or using public cloud infrastructure as a service. Private IoT cloud is secure, protecting sensitive customer data and ensuring consistent performance of mission-critical and real-time applications. In our own practice, we have been engaged in projects where the customer had to migrate IoT solutions from a proprietary platform deployed on a public cloud to a private IoT solution based on the Ka platform. On several occasions, the migration of the application's logic became overly complicated due to the limited access we had to the proprietary technology. This complication resulted in extra development cycles when transferring applications to a private or hybrid Ka-based cloud. After these hurdles were overcome, the customer is now able to add, change things at their own pace, using any engineering resources they or their partners have. They can also integrate any hardware or use other third-party software for their end-to-end solution. We use this example to underscore that in order to build a private IoT cloud that is customizable and manageable, it is important to do so using open IoT technology. Apart from effectively addressing interoperability challenges, a private IoT cloud allows for a more flexible implementation strategy. Not only can it be used for internal device management, but it is also very effective in implementing a variety of cloud services for your customers and for deploying large-scale IoT solutions. You can basically create and develop a logistics-oriented IoT cloud that your clients and partners can use to optimize their own operations. This way, in addition to streamlining your supply chain activities, IoT can become a core expertise and the key differentiator from your competition. The new release of Ka IoT platform, Banana Beach, is specifically tailored for developing private IoT clouds. Major enhancements introduced in Banana Beach render Ka an ideal platform for continuously evolving corporate environments, cross-technology domains, and consistent security and performance. Ka's microservices architecture allows engineers to assemble and deploy IoT solutions out of specific services. You can also add your own third-party services to the platform, thus creating custom IoT solutions with minimal integration and development effort. A microservices architecture also reduces costs associated with IoT projects because now you can add specific components that are needed by your applications and avoid implementing or hosting any unnecessary components. Microservices is also one of the best ways to deal with enhanced functionality. Dockerized microservices allow you to deploy features selectively and independently from each other, and also allow your DevOps specialists to spend much less time on configuration and provisioning tasks. The Ka Banana Beach platform will be made available to the general public at a later date. However, we do already have several deployments in commercial projects.